Hello friends, myself Professor Prakash Jakatdar. I have been coaching for IIT entrance examination for the last 40 years. And during that time, I came across many such topics which I always found very interesting. And I want to make those topics interesting for you. Unless you master these topics, you're not going to go ahead in your mathematics syllabus. Okay, so mathematics syllabus consists of functions, right? And there are topics like calculus which start with limits and continuity. They actually begin with the functions, the concept of functions. And concept of functions I already discussed in some other lecture. But I'm going to talk today about certain special types of functions. You know, these special functions always comes in the problems of limits, continuity and differentiability. And whenever these functions come, their behavior is totally different from other kinds of functions. Other kinds of functions are different than this kind of functions. That is why these functions form the core of those problems which appear to be difficult. So if I'm a mathematics paper setter and I want to create a difficult problem, then for me, I want to create a recipe, and that recipe contains these ingredients. That means these special functions are the ingredients to create what? Slightly difficult problem, or let us say not difficult, but slightly different kind of problem, you know. So let us get into the idea of these special functions, their visualization, that means their graph and all that, okay. So the topic today is special functions. Special functions. Now, basically, I'll make a list of all those special functions. Number one, this function is called fx is equal to mod x. Now, it is called modulus of x, or it is also called absolute value of x. The what it is and all that I'll tell you later on. Let me introduce second function. That function fx is square bracket x. Now this function is called greatest integer function. Greatest integer function, or it may be called integral part. Integral part of x. Okay. Now there is a third function, and that is always denoted by a curly bracket, and x is enclosed in a curly bracket. So this is called fractional part of x. Fractional part of x. Okay. And the fourth function, whose behavior is exceptionally different than other functions, is called fx is equal to e raised to 1 upon x. Now these functions are very, very important functions because of their behavior. They don't behave normally. They are, the kind of backbenchers in the set of functions. Their behavior is unruly, right? So you have to deal with them first. And once you have mastered the art of dealing with them, then you will be expert in the finding out limits, continuity, differentiability in all such problems in IIT as well as CET or as well as 11th standard examinations will be very easy. So for that, it is absolutely necessary to first of all look at these functions. Okay. So we'll go by one. Okay. The first one is modulus of x. What is modulus of x? So let us take the first one. Okay. The first function is y equal to mod x. What is mod x? Basically what we are doing is we take any real number, any positive or negative, we strip its sign. That means its sign is removed. and we just keep that number. That is what is called absolute value. What is the absolute value of minus 2? If you remove the sign minus, then you will get 2. And if it is already 2, then you don't have to remove anything because it is already 2. Correct? So, what I mean to say is this, that if I want to find out absolute value of 3, for example, then absolute value of 3 before 3 there is no sign at all. That means it is assumed to be plus. That's a convention. So, therefore, mod of 3 will be 3. Okay? Now, suppose I have mod of minus 3. Now, I don't want this minus sign. I told you, I have to remove this minus sign. I want positive answer. So, what will I do? What can be done to this number? One additional minus sign can be put before it. Okay. So, for example, if I write it like this, minus of minus 3, then the number becomes what? 3. So, even in this case, the answer turns out to be 3, which is a positive number. In this case also, the answer turns out to be 3 because it is a positive number. So, that means if I want to define mod of x, I will define it like this, that if x is positive, then mod of x is nothing but x. Mod of x is nothing but x. But if x is negative, then mod of x, because x is negative and I want answer to be positive, I will have to attach a minus sign to x. Correct? Remember, this x itself is negative. So, negative plus negative, double negative gives you positive number. Okay? So, under any circumstances, the answer will be positive. Okay? So, let us take some examples. For example, suppose I ask you, what is mod of minus 10.1? Now, mod of minus 10.1. Minus 10.1 is a negative number. So, I will apply this definition. Right? So, therefore, this is equal to what? Minus of minus 10.1. That gives you what? 10.1. That is the absolute value. In other words, we have removed the sign, minus sign, and we got only the plus. Suppose I want to find out what is the modulus of 99.9. Very simple. Is already positive number. अगर positive number है तो उसका mod वही होता है. That means this is equal to 99.9. So it's very simple that whenever you want to find a modulus of x, if x is positive, then it is x only. And if x is negative, then it is minus of that number. Okay. So that is how the definition of mod x is. Okay. Now look at this. I will look at another way of looking at mod x. You are all familiar with real line, correct? So there is a real line. This is a real line, right? In the middle of which there lies the greatest hero of all time, 0, correct? And on the right side, there are positive real numbers. On the left side, there are negative real numbers, positive. And this side, there are negative real numbers, right? So, if I ask you what is mod x, I will say it is nothing but distance of that point from 0. For example, 2. How much distance is between 0 and 2? 2 units, correct? So, 2 units. So, it will be ye 1 hai, right? Or ye 2 hai. So, what is mod of 2? Mod of 2 is a distance of 2 from 0. Okay? So, mod of 2 is distance of 2 from 0, right? Now, if I say, if mod of x is equal to 2, then how many numbers satisfy this criteria? Those numbers which are at a distance 2 units from 0. So, now numbers which are at a distance 2 units from 0 are on both sides. We can either go on this side 2 units, मतलब 2 units आगे जाओ, नहीं तो फिर से 0 पे आ जाओ और पीछे जाओ, दोनों 2 units पे है. So this is -1 and this is -2. इसका भी distance 2 units है, correct? ये distance भी 2 units है, correct? So you can either go backwards 2 units or forward 2 units. So therefore mod of x is equal to 2. If I want to find a solution of this, इसके solution दोनों है, एक है 2 और दूसरा है -2. So there are two solutions, right? Mod of x is equal to 2 means this. In other words, in general, if I ask you what is the solution to this problem, mod x is equal to a, then the answer will be x and what? Minus x. Correct? So a can take values x and minus x. Okay? So sorry, not x and minus x. It will be a and minus a. Sorry. Okay. These are the two values that we can take. Okay. Yes. So what is mod x? Geometrically speaking, distance of x from 0. That is called mod x. So if I ask you mod of 11, how much distance it is away from 0? 11 units. So it is 11. Minus 11, mod of minus 11. How much distance is there between minus 11 and 0? 11 units. Therefore, it is a distance from 0. Okay. So now let us see what is the graph of this function. Okay. So graph of this function is like this. Let's remove this first. Okay. Now graph. Graph of mod x. For graph, we need to draw x-axis, and y-axis, right? Y-axis. Y-axis, okay? Now, our function is very clear. Y is equal to mod x. Y is equal to mod x. Y equal to mod x is defined like this. It is equal to x when x is positive. That means it is a graph of the straight line y equal to x. Y equal to x. So whenever x is positive, it's a line y equal to x. Now what is this line y equal to x? X and y are same coordinates. So this line will intersect the entire angle between the positive direction of x-axis and positive direction of y-axis, exactly bisect this angle. So it will be like this. It will start from here. It will start from here and it will bisect this angle. This line is called what? Y equal to x. This angle is going to be 45 degrees. Correct? So that is an angle bisector of the angle of the first quadrant. Okay? Because here every point will have y equal to x. Now, when x is negative, then y becomes not x but minus x. So now, this is a graph of what? Y equal to minus x. It is another straight line, but iska slope tha 1. So tan theta was 1, so therefore theta was 45 degrees. But here, iska slope hai minus 1, so tan theta is minus 1, so slope is 135 degrees. That means it is the same counterpart. यहाँ से अगर हमने 45 degrees angle निकाला और ये अगर line निकाला यहाँ से ऐसा, right? So this angle is again what? 45 on this side, but this side the angle is 135 degrees. Okay, so this graph is called y equal to minus x, right? So these are the two straight lines that make up this. So the graph is V-shaped, So if you have understood this particular concept or this particular function, you have got every reason to be victorious because it's V-shaped, correct? Remember, this graph is symmetrical with respect to what? Y-axis. What do I mean by symmetry? Symmetry means if I fold this graph along this line, imagine I have drawn this graph on a paper and on this line I fold it, then this part of the graph will overlap this part of the graph. So the graph is symmetrical about x-axis. Okay. No part of the graph is below x-axis. That means the graph can never become negative. Okay. So this graph can never become negative and it is symmetrical. So the graph is symmetrical about a y-axis. Correct? That means this part and this part, they are mirror images of each other. If you hold a mirror along the y-axis, graph is symmetric. Then no part of the graph lies below x-axis. Now, you can calculate mod of any real number. You can take mod of any real number. That means the domain of this function is entire x-axis from minus infinity to plus infinity, all real numbers. There is no problem in finding out mod of any real number. So we can take all real numbers. There is a domain. But range is what? What values it will take? It is not allowed to take values between 0 to minus infinity. It is allowed to take values between 0 to plus infinity. Right? So this happens to be the range. Okay? So the range is from 0 is included, to infinity. Infinity can never be included because we can never reach infinity. This square bracket indicates that this end is included. Round bracket indicates that this end is not included. Correct? So this is how the property of mod x is. These are the properties of mod x. Symmetric about y-axis. No part of the graph lies below x-axis. Domain is minus infinity to plus infinity. Range is 0 to infinity. This is the basic information about mod x that you should realize. Okay? Fine. So now, let us go over to the next function.
Sir,
now, let us get on with the second function. Second function is denoted by a square bracket x. Now, it has got a very interesting name. It is called greatest. Greatest integer less than or equal to x. Greatest integer less than or equal to x. For example, if I give you a number, say 2.1, okay, and this is a real line. Here is a real line. ये number है 2.1. So उससे छोटा वाला integer चाहिए. ये integer नहीं है. This is 2.1 is real number, not integer. उससे छोटा वाला integer कौन सा है? 2. उससे भी छोटा वाला कौन सा है? 1. उससे भी छोटा कौन सा है? 0. उससे भी छोटा कितना है? -1. So how many integers are less than 2.1? Infinitely many integers are less than 2.1. No doubt about that. Among those infinitely many integers, which is the greatest? Greatest is this one. So this is a greatest among all integers which are less than 2.1. Then 2.1. Correct? So all these integers are less, but among them, this is the greatest. Yeah, this stands out. This is the greatest. So you can always say that it is an integral part of x because this number is made up of two parts. One is a decimal fractional part, integral part. So this is an integral part of x. That means if I give you what is the integral part of 2.1, then you can look at it. This number is made up of two parts. One is 2 and another is 0.1. So this number is actually what? 2 plus 0.1. So इसका integer part ये है और ये fractional part है. So therefore this is equal to 2. Okay. But this interpretation gets into problem because of negative quantities. So for example, suppose I ask you, in other words, you must have realized that any number x, any real number x lies between two consecutive integers. इससे पहले वाला एक इंटीजर होता है इमीडिएटली पहले वाला और दूसरा इमीडिएटली बाद वाला होता है. सो ये जो नंबर है n, जो इसका इमीडिएटली एवरी रियल नंबर कैन बी ट्रैप्ड इन टू कॉन्जिक्यूटिव नंबर्स. फॉर एग्जाम्पल 3.9 इज लाइंग बिटवीन 3 and 4. करेक्ट? 3 and 4. 2.11111 कितना भी होने दो, इट लाइज बिटवीन व्हाट? 2 and 3. करेक्ट? तो ये जो दो इंटीजर्स है उसमें से लेफ्ट वाला इंटीजर हमको पिकअप करना है. करेक्ट? So that is what the greatest integer function is. Now in case of minus, for example, suppose I want to find out greatest integer part of minus 3.4. Correct? In case of plus 3.4, it was just 3. So you may say that minus 3.3, it will be minus 3. No. We want an integer which is immediately close to this number, but to the right. To the left. So just draw the diagram and you'll come to know. Very simple. This is 0, correct? This is minus 1. This is minus 2. This is minus 3. This is minus 4. Now, where exactly this particular integer lies? It lies here. It is this number is what? Minus 3.4. And we are interested in the integer which is lying to the left, immediate left. And that integer is not minus 3, but it is minus 4. So, in this case, it is what? Minus 4. Is it clear? So therefore, remember, greatest integer function is like this. So I'll give you several examples and you will tell me, you will realize what I mean by integer. Okay? Okay, so let us forget it. Okay? So, for example, if I ask you, what is the greatest integer of 2.9. Now 2.9 lies between 2 and 3. So on the left hand side there is a number 2, on the right hand side there is a number 3. We want to find out the left side. So 2.9 का integer part है, 2.9 का integer part है 2. Correct? Now ये जो है, so if I take minus 2.9, then minus 2.9 will lie between minus 2.9, will lie between minus 3 and minus 2. तो उसके लेफ्ट साइड में कौन सा इंटीजर है वो हमको पकड़ना है, वो है minus 3. So यहाँ पे ये क्या आएगा? minus 3. Now if you take integer itself, for example, what is the greatest integer? Less than or equal to. Remember, in this definition, equality is allowed. तो इसका integer part integer वही है. So 3 is 3. Simple. So if you take any integer, its value is same. If you take positive number, उसका value है उसके left वाला integer. Minus लिया तो भी उसके left वाला integer. Correct? So, for example, let us get familiar with this function. Okay. So, suppose I ask you, what is x plus integral part of x? For x is equal to, suppose I write here 3.1. X is equal to minus 3.1. X is equal to 5, x is equal to minus 5, x is equal to minus 6.7, correct? And I want to find these values. Fine. So this will be what? First, इसका क्या value आएगा? देखो, x plus integral part of x or greatest integer function x. तो वो आएगा x का वैल्यू हमको क्या है इधर 3.1. So it is 3.1 plus integral part of 3.1. Now 3.1 lies between two consecutive integers 3 and 4. इधर 3 है, इधर 4 है और बीच में 3.1 है. The integer to its left is 3. Therefore, this is nothing but 3.1 plus 3. So answer will be what? 6.1. So the first answer is 6.1. Now, let us take the second example. Second example, x plus integral part of x. What is that? That is minus 3.1 plus integer part of minus 3.1. But minus 3.1, if you look at it, this is 0, this is 1, this is 2, this is 3. So ये minus 1 है, minus 2 है, minus 3 है और minus 3.1 will be somewhere here. Minus 3.1 और उसके left वाला integer है minus 4. तो उसके immediate left वाला integer minus 4 है. तो इसका आंसर आएगा minus 3.1 plus minus 4. Okay. So minus 3.1 plus minus 4, that gives you minus 7.1. Correct? So that is how you can calculate the answers. Okay. So we are interested now in finding out graph of y is equal to square bracket x, greatest integer function. So for that, we'll draw, as usual, we'll draw y-axis and we'll draw x-axis. Okay. This is x-axis and this is y-axis. Okay. Now just observe one thing, that suppose x is 0. Let us say x is 0. Then y is equal to integral part of 0. But 0 itself is an integer. Therefore, its integral part is 0 only. Correct? Now, if x is 0.1, now 0.1 will be somewhere here, 0.1. So this 0.1 lies between 0 and 1 or not. So the immediate integer to the left of 0.1 is 0 only. So value of 0.1 is 0, that will here only. This is the value. Okay. Now if I take, so what is y here? Y is integral part of 0.1, but 0.1, the integral part is 0. Now if I take x is equal to 0.11, then also y is integral part of 0.11. 0.11 will be slightly ahead of 0.1, so it will be here. But still, the immediate integer to its left is 0. So you can understand all the values between 0 to 1, but just before 1, they will have values. For example, if x is equal to 0.9, right? X is equal to 0.9. So y becomes integral part of 0.99. Suppose x is 0.99. So this is equal to 1. This is equal to what? This is equal to 0. Correct? Because 0.99 also lies between 0 and 1. So integral part of 0.99, and you can understand, I can write it 0.99. Therefore, the integral part is 0. Now, the moment x reaches 1, then y becomes integral part of 1, but then it is equal to 1. Correct? So now, before 1, it was coinciding, all the values were 0, but at 1, suddenly the graph takes a plunge of 1 unit. So it goes 1 unit up. Correct? Now, all the numbers between 1 and 2, now x here, if x is lying between 1 and 2, no matter where x is, anywhere here, okay, anywhere here, right, is the integer to its left will be always 1, so the graph will be like this, okay, but here there will be a round, because at 2, it will become 2, so it is 2 here, so it goes like this. So between 2 to 3, the graph is like this. Then here it is open, but here it is closed. So at 3, it becomes like this. And then 3 to 4. So the graph goes on like this, And below also it will go like this. like this. So it will be here, then here, then here. So this graph looks like steps. These are all what? Steps. It takes a value, same value between 0 to 1, again same value between 1 and 2, again same value between 2 and 3. Between 0 and 1 it takes 0 value, between 1 and 2 it gets 1 value, between 2 and 3 it takes 2 values, and between 3 and 4 it is take. But at all integer values it takes itself as a value. Correct? So this is called, that is why it has got another name called what? Step function. It's like, we have got a straight line and we are cutting it at every 1 unit. So ये 1 unit इधर रखा और ये 1 unit इधर से displace करके इधर रखा. फिर ये 1 unit लिया, ये यहाँ से displace करके यहाँ लिखा. फिर ये यहाँ से यहाँ पे कट किया, इसको यहाँ पे लिख दिया है. ऐसा. That means we are cutting that straight line into several 1 unit parts and replacing them above each other so that they form a ladder or they form a staircase. Now some of the properties of these functions are quite interesting. So let us illustrate some of them. Okay. So for example, so you know that if I take x, suppose I take x, okay, and I take its integral part, okay, and suppose I add to its integral part of minus x. Very interesting. Let us take an example. Suppose x is 2.1, okay, and here it is minus 2.1. You know what is the answer? 2.1 का integral part 2 है, लेकिन minus 2.1 का integral part minus 3 है. So answer will be what? Minus 1. Minus 1. Minus 1. Minus 1. But surprising part is it is always like that. For example, let us take another example. Integral part of 5.8 plus integral part of minus 5.8. What will be that? 5.8 positive number hai. It lies between 5 and 6. Therefore, integral part is 5. Minus 5.8 ka integral part is minus 6. So, this is equal to what? Minus 1. So, in other words, it looks like that this answer will be always minus 1. But it is not. In case of integers, it is different. Suppose if I take integer 3 plus integral part of minus 3, then the answer is 3 minus 3. It turns out to be 0. So this is the case whenever x is not an integer. So x plus integral part of x plus integral part of minus x is minus 1 whenever x is not an integer. But if it is integer, then it is 0. Right? So that's a very interesting property which can be useful for solving many problems. Okay. So our observation is what? See, look at this observation. Integral part of x plus integral part of minus x, is always minus 1 if x is not an integer. But this is equal to 0 is equal to 0 if x is integer. Okay, so very interesting function, and we'll do a lot of problems based on this function little later. Okay, so for today's lecture, I think you must have understood two functions. One is mod x, absolute value, and the other is called greatest integer function. To summarize, mod x has a graph V-shaped. It always takes positive values. Geometrically, it means mod x is the distance of x from 0. Okay, that is the geometrical meaning. So, if I want to solve the equation mod x is equal to a, then there are two possibilities, either 2 or minus 2. That is the basic part. And then greatest integer function. Every real number always is trapped between two consecutive integers. So, the integer which lies to its left is the value of that function. For example, 3.1 lies between 3 to 4. So, its integral part is 3. But minus 3.4 will lie between minus 4 and minus 5. The integer which is lying to the left of it, it will be minus 4. Correct? So, that is how we have defined these two special functions. And there are two remaining special functions which we will discuss in the next part of our lecture. Thank you very much.